global warming is worse than you thought. The science behind this statement. How you can help. There are some rarely reported aspects of global warming that are of critical importance for everyone, but especially those under 65. The story starts in 1958 when Dr. David Keeling set up an atmospheric CO2 monitoring station at 11,140 feet above sea level on Mauna Loa in Hawaii. It has been operating ever since, tracking atmospheric CO2 levels. These are called Keeling curves. These are the result in parts per million, ppm, up to 2010. The sawtoothing is due to seasonal variations. The rate of photosynthesis in the northern hemisphere is highest in spring and summer, during which they take up CO2 and lower CO2 levels. When the leaves die in the fall and winter, the CO2 levels increase. Climate change and the progressive increase in CO2 levels led to the initiation of the Conference of Parties, or COPs. There have been 27 COPs where most of the countries of the world have met to commit to reducing their CO2 emissions. Everyone hoped the Keeling curve would start to turn downward as shown. It was even hoped the rate of increase would decrease from 2 ppm per year to 1 ppm per year. So, what were the real results? The opposite is occurring. This shows that the level of CO2 in the atmosphere has increased from about 320 ppm in 1960 to about 420 ppm in 2020. Until we get emissions under better control, this steady increase is expected. But what is not expected is the steady increase in the rate of increase of CO2. In 1967, this was 1.0 ppm per year. In 1987, it was 1.5 ppm per year. In 2007, 2.0 ppm per year. In 2017, 2.5 ppm per year. And in 2023, 2.8 ppm per year. David Keeling died in 2005. His son Ralph, also a professor at Scripps Institute of Oceanography, took over monitoring the Keeling curve. In 2023, his group published a paper showing the same result as in the previous figure, namely that the rate of increase in atmospheric CO2 is progressively increasing. This was measured with the variable atmosphere growth rate, or AGR, measured in gigatons carbon per year. It increased from 1.8 in 1960 to about 5 in 2020. Thus, two different variables, ppm per year and gigatons carbon per year, each show a steady increase in the rate of increase of CO2 accumulation. So, why is this happening? One possibility is the large amount of emission from China. This shows that China's emissions slowly increased from 1960 to 2000. It then rapidly accelerated from 2000 to 2010 and leveled off from 2010 to present. This is distinctly not the pattern of the continuous steady increase in the rate of accumulation of CO2 shown in the previous figure. A better possibility relates to tipping points. A climate change tipping point is a critical threshold at which point a modest additional change in the causative factor leads to a significant and potentially irreversible positive feedback loops. As the feedback loops continue to slope, or rate of increase in atmospheric CO2 would increase, which is precisely what the two previous diagrams show. Many potential tipping points have been described. They can be divided into two groups, those directly resulting in an increase in the level of greenhouse gases, especially CO2 and methane, and those that do not primarily affect the level of greenhouse gases. An example of the latter group would be the melting of the West Antarctic Ice Sheet, WAIS, resulting in a significant increase in sea level. Only the tipping points that directly add CO2 or methane to the atmosphere will be considered here. Although none of them have been fully activated, many of the CO2/methane tipping points have been partially activated, and adding them together may be equal to or greater than a single fully activated tipping point, including a positive feedback irreversibility. The following are examples of partially activated tipping points. Wildfires are occurring all over the world. One severe fire season can release a level of CO2 that totally wipes out a whole country's efforts at emissions reduction. In some years, forest fires have accounted for 10 to 15% of all global greenhouse gas emissions. A boreal forest grows in regions of the Northern Hemisphere with cold temperatures, such as the Yukon Flats National Wildlife Refuge shown here. Due to climate change, the frequency of boreal fires has increased fourfold since 1988. Canada's boreal forest fires in 2023 released more than 3 times as much carbon dioxide as the entire country emitted from burning fossil fuels. Yukon Flats National Wildlife Refuge covers a uniquely vulnerable type of permafrost called Yadoma, which contains deep ice wedges that often melt after fires. This causes the land to collapse, exposing the ancient carbon to microorganisms and releasing greenhouse gases. Peatlands cover only about 3% of the Earth's land surface, but store approximately 30% of the world's soil carbon. The carbon stored by peatlands is at least twice as much as all other vegetation types together. Burning peatland releases 0.5 to 1 gigatons annually. The Indonesia fires in 1998 and 2015 released up to 2.6 and 1.6 gigatons of CO2, respectively. Emissions from draining peatlands results in the release of approximately 1.9 gigatons of CO2 annually, equivalent to 5% of global anthropogenic greenhouse gases. In addition to forest fires, humans add additional deforestation by cutting down trees for both lumber and to clear land for agriculture. This deforestation contributes to 12 to 20% of global greenhouse gas emissions. As a result of deforestation and degradation, some tropical forests now emit more carbon than they capture, turning from a carbon sink into a carbon source. The oceans are a huge CO2 sink. They hold 60 times more carbon than the atmosphere and absorb almost 30% of carbon dioxide emissions from human activities. The amount of CO2 the ocean can absorb is critically dependent on temperature. The average temperature for seawater is 15 to 18 degrees Celsius. Recently, some parts of the ocean have reached 100 degrees Fahrenheit or 38 degrees Celsius. This would result in a 50% decrease in the ability of the ocean to hold CO2. The excess CO2 in the atmosphere traps an enormous amount of energy, roughly equivalent to 5 Hiroshima-type atomic bombs worth of heat energy going into the ocean every second. This means that every day, 432,000 atomic bombs worth of excess heat energy enters the ocean. This shows the result of this heat transfer into the ocean. Rising ocean temperatures bolster the energy exchanges from ocean to atmosphere, increasing the quantity of atmospheric moisture, and change the patterns of precipitation and temperature globally. Among other effects, this means more severe hurricanes. This figure shows the increase in heat content of the ocean by year in zettajoules. That is a 1 followed by 21 zeros. This produces another variable called Earth heat imbalance. This is the ratio of the sun's energy in versus the Earth's heat radiating out in watts per square meter. The heat imbalance has doubled over the last 20 years from 0.42 watts per square meter between 1974 and 1993 to 0.87 watts per square meter between 2004 and 2010, and 0.96 watts per square meter between 2011 and 2023. 90% of this excess heat is absorbed by the oceans, making them less able to absorb CO2. This is largely the result of the loss of albedo due to the melting sea ice. This is a classic partial tipping point loop in that the increased heat melts sea ice, which decreases albedo, which in turn radiates less heat out, increasing the heat imbalance. Beneath the Arctic's frozen surface, there are huge amounts of organic carbon matter in the form of frozen soil and ancient plant matter called permafrost. It is estimated that there are 1.7 trillion tons of carbon as methane and CO2 are stored in the Arctic permafrost. This is 250 times the amount of methane currently in the atmosphere. When permafrost melts, it releases large amounts of methane, which is 80 times more potent as a greenhouse gas than CO2. In Alaska alone, over 80 sites like this of melting permafrost have been found. It is estimated that even larger amounts of methane are stored deeper underground as fossil methane. When this melts, it does so in an explosive manner, which produces large sinkholes. While the absorption of CO2 by the oceans is well recognized, it is much less appreciated that some areas of the ocean also release huge amounts of CO2 back into the atmosphere. These areas are shown here in red. The areas of the greatest year-round CO2 outgassing, red, are in the equatorial Pacific west of Ecuador. Other more seasonal areas are the Arctic Ocean, the Southern Ocean around Antarctica, and the Arabian Sea. Altogether, they amount to 6.85 to 12.65 gigatons of CO2 per year. CO2 outgassing. It is generally considered that when balanced against the amount of CO2 absorbed by the ocean, it is net zero. However, it is likely that as the ocean warms, the balance will tip in favor of outgassing, leading to significant bumps in atmospheric CO2. 1.3 to 2.5 gigatons of CO2 per year are taken up from the soil and then emitted into the atmosphere from streams and rivers each month worldwide. The red dots show the rivers with the largest releases of CO2. The soil is also a large reservoir of carbon. Warming increases the rates of CO2 production, thereby exacerbating the CO2 loading of the atmosphere and providing positive feedback to climate warming. Large surfaces of ice producing an albedo effect by which the sun's heat energy is reflected back into space, cooling the planet. The pair of gray satellites have shown that Greenland and Antarctic glaciers have lost mass at the rate of 199 plus minus 32 gigatons per year during a 14-year period from 2002 to 2016. This, along with the loss of sea ice, destroys this albedo effect. There is clear evidence that this is already having a major effect. The Arctic region is warming up to 4 times faster than elsewhere. This is called Arctic or polar amplification. While several causative factors have been suggested for the loss of sea ice with the resultant loss of albedo, it is the best documented case. In this figure, the red areas show the effect of this loss of this albedo on Arctic warming. The loss has several indirect effects, such as increasing the Earth's heat balance, permafrost melting, increasing forest fires, and decreasing land and ocean CO2 sinks. It's rarely appreciated that phytoplankton in the ocean, such as these coccolithophores, sequester as much CO2 and produce as much oxygen as all the trees on land. If these die off because of increased temperature, ocean acidification, deoxygenation, this huge reservoir of carbon dioxide will be lost. It would be the equivalent of a massive underwater forest fire. The size of ocean biomass production in a given area is referred to as net primary productivity, or NPP. In the April 2023 heat wave, NPP dropped by 22% in the equatorial regions of the Atlantic and Pacific, as well as the Northern Atlantic. All of these areas exhibited increased sea surface temperatures, SST anomalies. The global ocean annual primary production has declined more than 6% since the early 1980s. Phytoplankton form the base of virtually every ocean food chain, making most other ocean life possible. A prolonged increase in ocean temperature would not only seriously compromise this important source of CO2, fixation in O2 production, but also affect the food source for other marine life and billions of humans. All the previous were examples of tipping points that have already become partially activated. Those that follow are examples of more drastic tipping points waiting in the wings for even higher temperatures. Gas hydrates are ice-like structures formed when water and low molecular weight mass gases such as CO2, H2S, and methane, CH4, combine into a clathrate structure. Since methane is the primary gas involved, they are termed methane hydrates. The word clathrate is derived from the Latin clathratus, meaning with bars or laceted. The figure shows two typical methane clathrates with 46 water molecules and 12 to 14 faces. Methane clathrates are especially common along the continental shelf, where they are stable for 300 to 600 meters under the surface and at the low temperatures close to the seafloor. These clathrates are white and burn easily because of their methane content. Worldwide, it is estimated that gas hydrates contain up to 12,000 gigatons of carbon, more than the amount of carbon held in all fossil fuels on the Earth. This shows why it is a dangerous tipping point. If ocean temperatures keep rising past 2 degrees Celsius greater than pre-industrial levels, this trapped methane could be released into the atmosphere with obvious consequences. As global temperatures increase, a point is reached at which plants on Earth begin to switch from photosynthesis, consuming CO2 and producing oxygen, to respiration, consuming oxygen and producing CO2. The green line represents total global photosynthesis. The red line represents current global respiration. The gray area is the current climate. Even at the current climate, there is a modest decrease in photosynthesis and the land carbon sink, while global respiration is increasing. It was concluded that tropical forests can only withstand an additional temperature increase of 3.9 plus or minus 0.5 degrees Celsius before reaching a potential serious tipping point in metabolic function. If a significant percentage of terrestrial plants were to switch from photosynthesis to respiration, the large amount of resultant CO2 would be catastrophic. Approximately 75% of greenhouse emissions are CO2. The rest are methane, nitrous oxide, and fluorocarbons. The latter three are far more powerful as greenhouse gases than CO2. The question is, how much additional CO2 from partial tipping points is entering the atmosphere and contributing to the progressive increase in rates of increase in CO2 accumulation? Greenhouse gases from multivariate partial tipping points equals MPPTP-GG equals forest fires plus boreal fires plus peat fires plus melting permafrost plus loss of albedo plus dying phytoplankton plus earth heat balance plus melting methyl hydrates plus photosynthesis less than respiration. This suggests that even if we approach zero emissions, the rate of increase in the level of atmospheric CO2 driven by multifactorial partial tipping points could continue to rise. Climate change affects all ages, from newborns to seniors. WHO 2024. Since pre-industrial times, the average global temperature has increased by at about 1.1 degrees Celsius. It is estimated that with business as usual, by 2050 the world will have warmed on average by 2 degrees Celsius since pre-industrial levels. For every 1 degree increase in global temperature, the effects of global warming will double in severity. 2023 was the hottest in 2,000 years, and it will only get worse. Wildfires, dying forest, droughts, floods, worsening hurricanes, mass migrations with political conflict, sea level rise, starvation, crashing insect populations, increased disease. In addition to continuing to decrease emissions, it will also be necessary to directly remove CO2 from the atmosphere. These are called negative emission technologies. It has been estimated that it will be necessary to remove 10 gigatons per year until 2050, and then 20 gigatons per year. This is more than 1,000 gigatons total. The most commonly used NET is direct air carbon capture and sequestration. CO2 in the air is captured with various techniques and buried underground. Chimeworks is one of the companies involved. While this technology can easily remove thousands and probably millions of tons per year, there are concerns whether it can remove and safely store gigatons of CO2. An NET that is capable of safely sequestering gigatons of CO2 is enhanced weathering. This figure shows the process of rock weathering in nature, where the process takes thousands of years. This is the chemical equation. If rocks such as olivine are ground to a 1 UM size, the reaction is complete in 2 weeks. The disadvantage of enhanced weathering is that gigatons of olivine must be mined, ground, and distributed for each gigaton of CO2 sequestered. There are many other NETs. What will be needed is the worldwide activation of many NETs on a massive scale. This will require considerable political will and commitment. During his presidency, Trump called climate change a hoax, placed climate change deniers to senior posts in the EPA, Department of the Interior, and others, withdrew from the Paris Climate Accord, to the applause of fellow Republicans.
The United States will withdraw from the Paris Climate Accord.
Trump's removing the U.S. from the Paris Treaty was based on an oil and gas industry report stating it would cost the United States $3 trillion in lost GDP and 2.7 million jobs by 2025, including 440,000 in manufacturing. In reality, since Biden re-entered the pact, U.S. GDP has grown by nearly 1/3, or $6.9 trillion, compared to the Trump administration's 2019 pre-COVID high. Since then, U.S. employment also is up by 5%, or 7.5 million jobs, including 130,000 in manufacturing. Trump's support of clean air and water is a no-brainer. He uses it to cover up his devastating anti-climate change agenda. In addition, Trump rolled back more than 100 regulations to protect air, water, endangered species, and human health, removed references to climate change from all government departments, rolled back key regulations on methane emissions, cut funding for NASA's carbon monitoring system, putting in jeopardy the ability to monitor emissions reduction targets, again to the applause of fellow Republicans. By contrast, President Biden re-entered the U.S. into the Paris Climate Accord, passed the Inflation Reduction Act, which provided billions toward fighting global warming. Of note, not a single Republican voted for this act, reset emission limits for both carbon dioxide and methane, funded multiple approaches to capturing CO2 from the air and ocean and safely sequestering it, and many others. If re-elected, Trump promised to dismantle the Inflation Reduction Act, withdraw from the Paris Climate Accord signed by 195 member countries, offer tax breaks to oil, coal, and gas producers, repeal federal subsidies for solar, wind, and other renewables, roll back Biden's efforts to encourage the use of electric vehicles, replace scientists with political appointees to handle pandemics and science-related problems, increase coal, oil, and gas production. Drill, baby, drill. In addition, the Heritage Foundation proposed Project 2025, which stated if Republicans win the 2025 presidency, the very first day they will cancel all programs in all government agencies aiming to combat climate change. Then, dismantle the Environmental Protection Agency, EPA, defund the Department of Energy, support more fossil fuel production, defund NOAA, the National Oceanic and Atmospheric Administration. NOAA is critical for monitoring the health of the atmosphere and oceans. The world is already years behind where it needs to be to halt global warming. If the Republicans win the White House, it would be disastrous for controlling global warming and could throw the Earth into an irreversible global warming feedback loop. By contrast, Harris and Walz are fully committed to combating global warming. If you love and value our planet, use your voice. Vote. The outcome will depend on you.
If this goes viral, it would help to protect our planet. To do this, send a link to everyone you know who is concerned about climate change and ask them to do the same.